Yes, hi everyone. Good morning. Yes, so what was the last topic that we have discussed? What did we discuss in the last session, guys? Yes, everyone.
We were discussing about encodings.
Encoding. Is it completed or not completed?
We discussed one thought encoding, sir. That's it.
Yeah. Okay, good. So let me share my screen and we'll start working on that. Just a minute. Where is our machine learning part? We can go while you share this. See now here, um, in the last session we have discussed this is completed. Detecting multicollinearity is done. Dealing with categorical variable is also done. Yeah. So as I told, there are two or three types of encoding that we are going to discuss in today's session. So basically, what we do is, as I told, suppose you have this data and first row is India, second is Australia, third is USA, fourth is Japan, fifth is Canada. So um, in your first row, wherever we have India, we create a separate columns for all the different unique values that we have for country. So India, Australia, USA, Japan, and Canada. Let's consider apart from this, we don't have anything, any values beyond this. So if else, I mean, let's consider, suppose in the next row itself, there would be India or there would be any values from this particular unique values or unique count only, right? So what we do is we create separate columns for all the unique labels that we have for country, and wherever there is India, then it will be one. Apart from that, it will be zero. Then Australia, here it should be one, and apart from that, it should be zero. And same for like this. And we don't do this manually. We write down pd.getDummies, which we are going to do it in today's session. And then generally what happens is, as I also have discussed that um, if you get only two values, right? Or if you just have only three values, at least three values. Other two values are obvious, right? You can obviously predict that. For an example, suppose this is 1. So apart from that, I mean, Australia, USA, Japan, Canada, it will be 0, right? Suppose if this is 0, Australia is 1, then it will be 0, USA, Japan. If USA is 1, then Australia, India, Japan, and Canada will be 0. So, likewise, we don't need to have all the columns out there generally, right? So, what do? We write down uh, parameters. Parameter you can consider drop underscore first is equals to true. So what we do is by using this is we drop any random first row, right? So we don't have any control like which particular country will be your first part of the column, right? Here it is India. If you are doing this in Python, you don't have any control. Like it will be Australia based on the alphabetical order. Or here, let's say if we have India first, if we write down drop underscore first true, it will drop this India column because that is not necessary, right? And even though if you don't have this India column, you will be having Australia, USA, Japan, and Canada, and you can easily uh, be able to predict what is there inside your India column, right? So that is your drop underscore first true. The second prominent reason why it should be useful is if you have multiple records, let's say if you are creating 1, 2, 3, 4, 5 columns. So what happens is generally the more the columns are, the more space it will take, right? Or more complexity will be there. Or you can say more time it will take to compute this, right? So instead of having multiple columns, we just generally drop one so that we'll be able to reduce a space little or more complexity, or we'll be able to reduce time as well, right? Somewhat less time it will require to compute and process that encoding or variables. So that would be another reason like why there is a need of encoding, and why there is no not need of encoding, why we drop the first value or first parameter over there, right? So we drop this because it is redundant. We drop redundant variable. It is known as redundant variable, or it is also known as dummy variable. This all are known as dummy variables. So that's the reason we write down pd.get underscore dummies in the Python. The second reason is, as we have discussed, if we have a data wherein we are having uh, columns in different range. So what happens is the column which has higher range, it will consider as your by default the nature of machine learning model is it will consider highest rated model or highest range column as the important one, and these are the least important one. So that is known as scaling effect, which we already have discussed in the last session. That where is this? If we have this, okay. So it will consider weight as the important one, right? And other are least important. And this particular effect of giving weightage, more importance to the specific column which has high range is known as scaling effect. So we need to scale our data in a single uniformed range, that is known as scaling. So that can be achieved by using mean max scaling or standardization. Both are good ways, and we are going to see when should we use scale mean max scaling and when should we use standardization, right? So there are two terms basically. Mean max scaling is also known as normalization, that we are going to see in today's session, and there is one thing which is known as standardization. So uh, that's what it is. Um, like we are going to see scenarios where we will be actually dealing with when should we go with the normalization, when should we go with the standardization. But there is no hard and fast thumb rule that we go with this normalization when we have a data like this, or we should go with the standardization when we have data like this. So you can go with any method out there, and that is also very, very important and very effective way to increase your accuracy, right? So that's the reason we should go with the scaling of the data. Now, let me check what do we have as part of our next uh, module. I think we have done with the residual analysis. Just a minute, just. So you just go through this, just revise this till now, whatever we have discussed, and let me just have a look at the syllabus. What is there as part of our next next module? Okay. All right. All right. Yeah. So once this is done, you're dealing with categorical variable and scaling part. We should just only touch model assessment and comparison. Anyway, this is a separate module, a separate topic that I want to take. So I'm not going to give more focus as of now, being just you guys being just um, beginner. We will not go in depth of this point as of now. So we have model assessment and comparison. Like once the model is built, you would want to assess it in terms of predictive powers. For multiple linear regression, you may build more than one model with different combinations of the independent variable, which we already have discussed, right? In such case, you would also need to compare these models with one another to check one yield optimal results as compared to other. So let's say we have this data. What we have done is we have just taken cylinder and displacement, and we have fitted your target variable is MPG, right? So we have just taken these three variables. This is your Y, and these two are your X. We have built a model. We have found the accuracy R2 score. Now we have taken another model in which we have HP, weight, and acceleration. So we just compare these two, right? So what are the metrics, different metrics, or what we can say tools that we use to assess and compare models are your F statistics, which is purely a statistics part, which is not included in your syllabus. So we are not going to touch that. Uh, we also have discussed R squared. So that is another tool which we use to assess our model. And we have adjusted R square, which we'll discuss now. That's the reason we have uh, written down this model assessment and comparison module. We have adjusted R squared. And what is that? We'll discuss this. So first of all, let me write down how do we select the best model. How do you select the best model? So there is a trade-off means competition. Trade-off means uh, one thing is pulling another thing. Like there is a strict head-to-head, neck-to-neck combination competition between your variance, the highest variance, and keeping it simple. So one pool of people, or what generally we have a strict competition between highest variance and keeping the model simple is, I'll just tell you this technical term in very, very simple and in naive words, just like we explain it to any layman out there, right? So uh, what we have seen till now is, in order to get highest variance, means highest explanation of the data, we should consider more number of variables, more number of independent variables. Like earlier, we have just taken cylinder, then we have taken displacement, then we have taken HP, then we have taken weight. So we are adding one independent variable with each other, and we are making our model complex, right? So there would be multiple independent variable, and that is known as taking help of uh, more number of independent variables to get the highest variance of the data. But what happens is, if you just take more number of independent variables, your model become complex unnecessarily, right? There might be chance that you might have some of the columns which are not necessary for you, which are not necessary for your model. You are taking that into consideration as well, right? So generally what happens is there's a trade-off between these two terms, that whether we should go with the more number of independent variables or we should keep our model as simple as possible, right? uh, Most of the, I mean, this is also equally important that your model should be as simple as possible, because unnecessary, if you just try to create a complex model, so your degree of the curve will be increased, right? It should not be a straight line. And as it is not a straight line, degree is higher degree curve, third degree, fourth degree, fifth degree. It becomes a complex model, and unnecessarily it will overfit, right? What is overfit? We are going to discuss that in after some sessions. But to just give you guys an idea what is overfit is, instead of that, what we can do is we can keep our model as simple as possible. Let it be this scenario, like I am in a position to miss these 2 points. I'm not taking into consideration, and that is totally allowed for me. Like that is uh, instead of taking these 2 points into consideration, I should have to, I will need to take higher degree curve like this, right? And that makes our model complex. And that also introduced the term which is known as overfitting, which we already have discussed. That is nothing but your high training accuracy, but testing accuracy substantially fails. The testing accuracy is very low, right? Your model will generalize well on the training data, which it has already seen. But when it comes to unseen data, your model fails, right? And when we call our machine learning model as a good model, is it should predict uh, it should predict with good accuracy for the unseen data, right? Anyone can, let's say if I have given 8 questions to you, and I told that any questions, any 5 questions from these 8 questions will come in your exam, which is going to happen tomorrow. You guys will be confident, right? And anyone can score 90 or 100 rather. But the main task is, we uh, should be able to answer questions which are completely unseen, like which are totally new to our model, totally new, right? Then only your model, you say that your model is performing well, right? Are you agree with this fact? In future, you will get data which your model has not seen, right? It is completely unseen to your model. Yes or no, guys?
Yes, sir.
So that's the reason it should also have a equally good testing accuracy on the testing set, which is completely unseen, right? So that is known as overfitting. Wherever your model is performing very, very well in your training set, its accuracy is very good, but testing accuracy is relatively low, and it's it's very low. I mean, suppose if you have 85% in training accuracy and only 65% in testing accuracy, if there's a difference between two accuracies, if it is greater than 5, we call it as overfitting, right? So less than 5 is totally acceptable. 80 till 80 is acceptable. 81 is acceptable, but it should not be more than 5%, right? So one of the key factor is, what we can do is, R square is also relatively poor as compared to adjusted R square. And what happens in adjusted R squared is, we kind of penalize models using higher number of predictors. So its formula is little complicated. You don't need to worry about that. Nobody is going to ask you that. But you should know the significance, like why adjusted r squared is introduced, right? So it goes like 1 minus 1, 1 minus r square n minus 1 divided by n minus p minus 1. And what we are doing is, let's compare this to r square and adjusted r square so that you'll get a clear idea about uh, the difference between them. So here simply we are taking 1 minus sum of square residual upon sum of total residuals. But as I told, you need to keep balance between highest variance and keeping model simple. This can be done, this particular thing can be done using the key idea, using the key idea that a model can be penalized for keeping a large number of predictor variables, right? So hence, there are two new parameters that come into picture. One is adjusted R squared, and one is AIC. That is also something uh, which we are going to discuss and focus more on after some time. It is known as Akaike information criterion, and that is nothing but formula. Don't we have? That also penalizes a model that use more parameters, in the sense like if we have high number of multiple independent variables, it penalizes the model, and the model with lowest AIC value is considered as the best fit. So we calculate this 2k minus 2 natural log of L, and you don't need to do this manually. You have a module for that, Python package for that, or coding for that. But you just consider we penalize the model which is using high number of or large number of predictor variables. So penalized term is taken as this p is there over here, k is there. You can consider this k is nothing but your penalized penalty. We penalize the model which is using high number of independent variables, right? Unnecessarily it is complex. So here n is the sample size, meaning the number of rows you would have in the data set. And there's one penalty p, that is nothing but it's the number of predictor variables. It's the number of predictor variables. Is it clear now? And most of the, I mean, this formula is also okay, but there's one more formula which is 1 minus 1 by r square, capital N minus 1 divided by, divided, sorry, it should be here, divided by, this entire term is divided by capital N minus this p penalty and 1 minus 1. So we have seen that n is the size of the sample size of the, meaning the number of rows you would have in the dataset. So overall key point over here is adjusted R square adjust the value of R square such that model with large number of variables is penalized. So I'll just write down main key important parameter. Is it my voice is less? Just a minute, let me check. I think it would be good now. Is it good now, everyone? Is it fine now?
Yes, sir.
Okay, okay, thank you.
Yes, Vibha.
So adjusted R square adjust the value of R square such that a model with a larger number of variables is penalized. And in next segment, we are going to talk about the feature selection. Like you guys will be having a question that this is fine. Like I want to penalize the model which is using higher number of independent variables. But what about this? Like how we generally select the feature or select the variables that we have to consider or columns that we have to consider, right? So that is another topic which we are going to touch, which is feature selection. And let me just maximize the font, make it bold, and this. Apart from this, you have AIC, Akai Key Information Criteria. You have BIC, and you have Mallows CP, which is beyond your uh, syllabus, but you can explore this. Mallows CP is there, BIC is there. So I can provide you link wherein you can read that to just get an idea about that, but which is beyond our scope. So we'll not discuss that. It's more statistical term, right? Now, now we are going to discuss how do you select features. So one crucial aspects of multiple linear regression that remains to be discussed is feature selection. When building a multiple linear regression model, you might have quite a few potential predictor variable. Selecting just the right ones becomes an extremely important exercise, right? So we have multiple n number of variables, but in that selecting just the right ones becomes an extremely important exercise. Now let's see how you can select the optimal features for building a good model, right? So as I discussed already, suppose you have here we have how many independent variables? One, two, three, four, five, six, seven, and eight, right? So there are two ways generally. What we do is we first way is uh first way is we build the model with all the eight independent features or variables. I'm just adding a steps over here. So let us add this as A. Then we have B step. That is we drop the features that are least helpful in prediction. That is high p-value in your which package? Stats learn, right? We have seen that stats model, right? We have fitted our model by using stats model library. So wherever if we have high p-value for all the models out, I mean, what we do is we write down stats model dot summary, sm dot summary, the model dot summary, and you guys will be getting entire statistical summary of your machine learning model, right? And from that, this summary, everybody knows this, right? We have done this. So I'll just take this, and in that summary, wherever your uh, p-value is high, we just drop that variable. That is least significant for us. So to just give you guys an idea here for this example, these are the p-values that we have. So this is the variable which is constant. We have to drop that. So wherever p-value is greater than 0.5, we drop that particular variable, right? So you can also take another example and see um, if we have p-value greater than 5 for any variable out there, and we just drop that. So we drop the features that are least helpful in predicting high p-value. Third point is we drop the features that are redundant using correlations and VIF. And last is we will rebuild model and repeat. We'll rebuild model and repeat. So note that the second and third steps go hand in hand. Second and third step goes hand in hand. And the choice of features to eliminate first, to eliminate first is very subjective. You will see this during hands-on demonstration of multiple linear regression, which we are going to do, which we are going to do. So you will get to see this in hands-on multiple linear regression. So indirectly, what I am doing is I am giving you guys notes, right? You can directly revise from this to just minimize your task of revision. Now, as we have discussed, this is first way. Second way could be what you do is you take a single variable, feed the model, find the R2 score. You take second variable, feed the model, and find the R2 score. You take third variable, feed the model, and find the R2 score for the cumulative model that we have created by using three variables. So likewise, let's say by taking single variable, you are getting only 48% R score, R2 score. Then by taking second variable, it is 55, then 60, then 68, then 79, 86 or 85, 90, and 96. So consider you have 20 independent variables. And at the end of, let's say, 10th variable, we are just taking 10 variables and we are substantially getting 96% accuracy, right? Let us add one or two more variable 11 and 10, and let's say we are getting 97% R2 score, and that is good for me. Whenever at this moment, if I add 13 and 14 variable, I can see that my R2 score is not increasing. It's very significant. I mean, it's not significantly increasing. It's just 97.1, 97.2. So you get to know that these two variables that you are selecting as part of your model, 13th and 14, is redundant, right? So second way is very time consuming, but that is also the case that we have. So this is first way, this is second way to select the features. Now, generally, this manual feature selection or manual uh, feature elimination, either this is known as elimination, this is known as feature selection, uh, is possible whenever you have less variable, right? But in real world scenario, you have 500 variables or columns in your data. So at that time, sitting and taking into consideration one at a time, or fitting a model with the 500 variable and reducing one by one, it is very time consuming. Yes or no? So you need to combine the manual approach and automated approach in order to get an optimal model relevant to the business. Now, hence, you first do an automated elimination. You first do and automated elimination, that is coarse tuning. And when you have small data, a small data set of potential variables left to work with, you can use your expertise and subjectivity to kind of eliminate a few other features. That is known as fine tuning. So you might have heard this word constantly nowadays, fine tuning an LLM model, or fine tuning a large language model or chat GPT or something like that, right? So that is known as fine tuning. What we do is generally there is an automated elimination, which is known as recursive feature elimination. We go with that RFE. So we have a, what we can say, a variable. We have a package which is known as RFE. We just import that, and we it will do automatically, right? So we come up with the point, like if we have 500 variables, we drop recursive feature. We use recursive feature elimination, and we drop, let's say, 450 irrelevant features. That is a 50 features out there by using automation or by using RFE, your automated elimination method, and subjected to the business importance of that particular variable. Let's say now you have 50 variables. Let's say we'll reduce that to 20 by using RFE again, and subjected to the business importance or interpretability of the columns. Let's say these are the 20 important columns, and as you guys will be or everybody knows like which variable can be important to the business problem statement out there. Let's say you want to predict price of a house, and I have five important variables like square feet, I have number of bedrooms, I have number of balconies, and uh, what we can consider is whether we have parking or not, right? Number of bedrooms. These are relevant features. But if you have some features like address, uh, then whether this building has watchman or not, n number of variables which are not important. So that is not making sense for your business problem statement, right? So you can drop that. So this is known as your expertise. You can use your expertise or expertise and subjectivity to eliminate few other features. That is known as fine tuning. That is what I have explained or written down over here. Right? Now is this thing clear? How we select feature? How do we eliminate that? Are you good with this, everyone? Yes, guys, I want you to communicate with me because more you ask questions, more your doubts will be getting cleared, right? And I also will get to know like you guys are understanding this. So it should be two-way conversation from now onwards. As I have discussed, like this is machine learning, everybody is new to this, but you should ask questions. Let's make it interactive.
Okay, Vipul. The RFE in that we are recursively remove the features, right? So
Yeah.
how it actually removes, because
Hmm.
we only know the target variable which one we are going to predict, right?
Hmm.
Yeah.
Okay.
So based on the null values and everything, it will remove, or how it will perform?
No, I can show you a demonstration of this, but this is not in our syllabus. What happens is you in Excel itself you can perform this RFE, right? I'll just tell you how you can do that, or I can share one video so that you can able to get
Hmm.
that.
Okay, Vipul. Sure.
In earlier days, what used to happen is we used to do this statistical calculations and moreover regression and everything by using Excel. I'm talking about very early days. Excel also supports this. If you just see, I'll just share my screen just a bit. But what happens is if we get a large data, it will fail, right?
Yes.
They also do have a capacity of doing regression and whatnot uh, by using this. We have an analyzed data with us. Long days, I need to recollect that just a bit. Long back, I have done that. Suppose you have this data. Let's call this as a data and data. Let me take a data just a minute. Let's take a data. Suppose this is my data. All control C, control V, right? What I'm doing is I'm selecting this, everything. And by selecting this, if I go to data, there's one option to add regression analysis. Advanced में जाके I think it was VBA and that kind of thing. Add-ins में था. Let me recollect that. I have not done this. Uh, it's been multiple. This is analysis tool pack VBA. This one. So you need to install this analysis tool pack, and which will give you all the results that we are getting by using stats model, right? To just give you guys an idea, let's watch one video of how we can use recursive feature elimination or what happens in the back end, right? Let's call it as RFA in Excel. So reference, not reference. See.
Data science friends. My name is Aman and I'm a data scientist. Recursive feature elimination.
Representation. Anyway,
Can you create can be training data?
this is what I have explained. See, what happens is, I'll just tell you in very simple words. You'll get this. See, suppose this is your data, right? What do? Is we fit our model. So we just take one model at a time. Or it is recursive feature elimination, right? Okay. We take all the models out there. I mean, all the columns out there, and there will be a chart, just like we get by using stats model dot summary, right? There will be a chart. We'll be able to get that by using Excel. And there are different statistical values, multiple values, wherein one value is p value, and it should be less than 5, 0.5. If it is high, let's say for an example, for time in minute, you have got highest probability compared to all the other independent variables like number of clicks, pages viewed, time and amount, and time in minute and amount spent. So time in minute, you got 5.25 probability, let's say. So what do? Is you recursively eliminate this feature. So first time it will remove, then you will fit the model. Then you guys will be having, let's say, three independent variables, and out of those three independent variables, pages viewed, for let's say you will compare probabilities of all the independent variables, and let's say pages viewed has 3.25, other has very less probability. 0.004. So what do? You recursively eliminate this. So this loop goes on and on manually or by using the Excel package or Python package. So suppose you have 30 independent variables, you draw this, you'll get 30 different probabilities. Out of those, one will be having maximum, you remove that, then will be 29, then 28, and 29, 27, 26, 25, like that. So it does like that in the backend, right? Uh, I earlier in my earlier days I used to teach this as well in Excel, but this is not in our syllabus and it is also not important, so we can eliminate that.
Okay. Thank you.
So what I used to do is I used to take data just like this and used to perform that data analysis by using that VBA tool or that package. And then as I told, we used to look at the probabilities, then remove, then probability, then remove, like that. So that is a manual feature elimination. But this is also known as recursive. And automated means you use a package and by with the help of that package, it will minimize the number of variables that you have, right? So that summarizes your entire linear regression plus multiple linear regression. In this, the topic that we have just touched and that we are going to discuss in more detailed fashion are this overfitting and underfitting. You just let me know that this we should discuss. Apart from that, I think we don't have any. Yes, you don't have any. Okay. All right. Yes. So now, having understood this theoretically, we will just go and do this in Python, right? So I'll just share a data set with you and we can start doing this. Multiple linear regression. And this is what we have. Okay. So do you guys have housing data set with you? I think we already have done fitting a model on that. Yes or no? Housing CSV. Yes, guys. Advertising is there. Okay. Day 18. Okay, you don't have that. Let me create a folder. Day 21. Or is it day 20 only? Okay. This is day 20. Let's rename this as today's date is 14th. Listen. So I'll just provide this data set. You can do simultaneously with me. Or if you're comfortable with just watching this, you can do that. Housing CS. Yes. Okay, we can do here as well. Let's create a new collab notebook. Create a share. Can close this. Let us upload our data. Housing. Yes. Okay. Well, let a model selection using RFE, that is housing case study, and we'll import and understand the data. We'll import warnings, warnings dot filter warnings in quotes ignore, and we can import pandas as PD, can import numpy as np, we can import, let's import the data. So housing is equals to pd dot read underscore csv. Right. Now, once I load this, I'll just check at the first 5 rows. Housing dot head, open and close bracket. Now, once we have done this, we will prepare our data. So as I told, we have some categorical variables and we have to deal with that. So we have main road, guest room, basement, hot water heating, air conditioning, preferred area, furnishing status. So out of these, we have main road, guest room, basement, hot water heating, air conditioning, and preferred area. This columns has only yes and no, right? Apart from that, you don't have any value for that. So it's a binary output, right? So what we can do is, I'll tell you one of the best ways in which to deal with the categorical variable. If we have only, let's say, two output, either it is yes or no, true or false. So we'll first create a list and we'll pass all the variables out there. So main road, guest room, basement, hot water heating, air conditioning, and preferred area. And I'm going to define the map function. In that, I am going to write down binary underscore map, and I'll return. Okay, we are getting searches. In that, I'm going to pass x, that is the number of columns, and it should return, the function should return x dot map. And we are just mapping, if I have yes in that particular column, I'm mapping that with 1. And if I have no, I'm mapping that with 0. Right? And I'm going to apply the function to the housing list. Let on housing variable list is equals to housing variable list dot apply binary underscore map. Right? And let's check the housing data frame, because we already have performed housing this operation of mapping yes with 1 and no with 0. So let's check housing data while using housing.head. So can you see now, for main road, guest room, hot water heating, air conditioning, and preferred area, we have zeros and 1. But still we have furnishing status column left with us. We can do the same thing, mapping with 0, 1, and 2. So for that, we'll just check the value counts for this. So we have three unique values. We can do same things 1, 0, and 2. But I'll just show you how we can do this by using dummy variable or one hot encoding, right? So let's put a heading as dummy variables, and let's write down the variable furnishing status has three labels. We need to convert these labels into integer as well. For this, we will use something called dummy variable. So the how do we generally do this is very simple. If you get to know this, you will be able to do this by yourself. And it's common for all the it's common for all the data set, or it's common generally, right? So I'll write down get the dummy variables for the feature. Which feature that we have? We have furnishing status. Furnishing status and store it in a new variable called status. So I'll write down status is equals to pd dot get underscore dummies housing furnishing status, and I'm going to check what the data set status looks like. I'll write down status dot head. Now you don't need three columns. You can drop. Could you share this data set, please? It's already there on your drive, or I have not uploaded that. I've uploaded that, right? Not there. Housing. Housing plus keys plus 3 using RFE. Right? And here, just don't get confused. Like you'll feel that this is categorical variable. This is not a categorical variable. True means 1 and false means 0. Your Python will also consider 0 as false and 1 as true. So it's 0 and 1 only. This is known as 0 and 1 only, but just in Boolean values, right? So you don't need to have all these three columns as I have discussed. Even though if you have two column, any two columns out there, you can easily predict what will be there in third column, like what will be there in unfurnished. So for first row, that is your 0 row, furnished is true means other two are false. This is true means other two are false. This is false. This is true means other is false. So you need to have only two, at least two, right? To get an idea about the third one. So we'll drop this, right? So I'll just copy this and I'm going to use the term drop underscore first is equals to true, and we will concat. What we'll do is, okay, we'll just take status head. So we have two columns out there. Now, what is the use of pd dot get underscore dummies? I have explained this, right, Gopi? Here, get dummies will do this zeros and one. Earlier, you have this column, categorical variable. Earlier, we had this categorical variable, furnishing status, in which we have a text kind of data. And as we know, machine learning does not, uh, in order to fit the model, we need to convert any categorical data into numbers. right? So get dummies will create a dummies like this, and it should be create it will convert it into zeros and one. And why here we are not getting zeros and one? Because true is, you can consider true as one and false as zero. And anyway, this is a number only, right? In just a Boolean representation of number. So if you write on one, is it equals to true? If you just compare, you will get true because one is considered as true in Python. Zero is considered as false. So this is zero, this is zero, this is one. Just like this. One means true, and these are the zeros. Then one, these are the zeros. Right? Is it clear? This one till now? Do you have any questions? Yes or no, guys? Now we have done this. It's time to just concat this in our data frame. So add the results to the original housing data frame. Let on housing is equals to pd.concat housing comma status. We are just concatenating, adding the status with the housing original data frame. And I'll just tell you why there is a need of dropping this. See, now you have converted this into zeros and ones, but we still have this with us, right? There is no any need of this because it already is explained by semi-furnished and furnished column. So we also need to drop that. This entire thing, what we are doing from 2-3 minutes, was just to convert this furnishing status into numbers, right? And we don't need to have this text kind of data. So that's the reason we need to drop that furnishing status. Well, let us drop furnishing status categorical variable as we have created the dummies for it. So I'll let on housing dot drop. I'm going to drop furnishing status. Furnishing status, comma access is equals to 1, comma in place is equals to 2. And I'll let on housing dot head, which will give me the output. Furnishing status is not there. Let us copy f is small. Furnishing status. So we'll split data into training and testing sets. So from sklearn dot model underscore selection, we'll import train underscore test underscore split, and we will specify this so that the train and test data set always have the same rows respectively. So df underscore train comma df underscore test is equals to train underscore test underscore split. In that we are going to pass housing train underscore size is equals to 0.7. Don't need to add test size, but I'll do that because if the test size is 0.3, obviously your training size becomes 0.7, right? So you can only add one parameter or both is also fine. And then random state is equals to 100. Any random state you can give, right? We have fitted the model. Now it's time to see, we have done this and handle the categorical variable. We are going to see the scaling, right? So what we'll do is we'll just call a package for min max scaler. I can write down this if if you guys don't know the package. So you just write down this and you'll go to official documentation of scikit-learn, wherein you'll get to know how you can import this. So you'll copy this, you will paste it over here, and you'll create an object instance, which we need to create by using the package that we have and just feed that. Call that. So creating an object instance, scalar is equals to min max scalar. And I'm going to apply a scalar, open and close bracket, to all the columns except the yes or no and dummy variables. So number underscore variables is equals to area, comma bedrooms, comma bathrooms, comma stories, comma parking, comma price. And df underscore train, number underscore variables is equals to scalar dot fit underscore transform, df underscore train, number underscore variables, vars. And I'm going to write on df underscore train dot head, open and close bracket. So generally, I'll just tell you what we do is there are three instances, or there are three method to just fit this scale or do the scaling. Let's discuss this 2 minute. So what we do is first way is to write down scalar dot fit. So it means we are just fitting our data in this object which we have created, scalar, right? But at this moment, scalar dot fit, it will not do the transformation, like it will not do the min max scaling. What is min max scaling is, it's simple. It's just like how it generally converts your data in zeros and one is, this is your formula, this one. So for an example, suppose uh, this is your data. Suppose we have three columns. We have square feet area. We have number of bedrooms. And let's say we have number of balconies, right? Now consider this is villa type of thing. Like I am going to add number of bedrooms as 5, 7. So don't get surprised like how we can have this. Just consider we are just trying to sell villas and bungalows, right? Now number of balconies also, let's say 10, 12, 15, 14, 5, 8, 9, any random value. And square feet is, let's say, 1200, 12,000. This one, this one, this one, this one, and this one, right? Now, what generally happens is it will use this formula in the backend, like how it transform the data. So here, for let's say for square feet column, what is your maximum value? What is your maximum value for square feet column? Your maximum value. What is that? Yeah,
14,500.
very good. And what's your minimum value?
11,000.
Right. Now for this, how it converts into zeros and one. Suppose this is your data, which is after you're doing min max scaling. Maximum is 4550, minimum is this. We'll put this x is equals to 12300. X minimum is this, x maximum is this, and we'll put the value. Right. So let us try to do that for the first record. So x 12300 minus x minimum is 1100 divided by x maximum is 14550, minimum is 11000. Right? Now same for this. 12304 minus 11000 divided by 14550 minus 11000. For this, it will be 0. Yes or no? X minus x minimum. So 11000 minus 11000. It should be 0. Anything divided by 0, 0 divided by anything is 0. And here 14550, it will be 1. So 14550 minus 11000. It is same as your x minus x min. Yes or no? So this is 1. And rest of the things will be in the range 0 to 1. Right? Yes or no? Same for number of bedrooms. Maximum value is 9. Minimum is 5. So wherever you have 5, it will be 0. Wherever you have 9, it will be 1, 0. And this is somewhere around 0s to 1. Right? You try this out by yourself, you'll get the same value. Number of balconies also, maximum is 14, minimum is 5. So for 5, it will be 0. For 14, it will be 1. Sorry, 15, it will be 1. And this is somewhere around 0.98, 0.57, something like that. So this is how it converts into zeros and 1. And can you now tell me, like if you perform min-max scaling, all the variables are in a single range, yes or no? That is 0 to 1. All the columns are in a single range. So will there be any problem of scaling effect? Will we have any problem of scaling effect which we were facing for this, or let's say for this, like by giving more importance, more weightage to the column which has higher range? Will we have any problem? Do we have any problem like this? If you perform min-max scaling? Yes or no, guys? So let us do that over here. Everyone should respond. Then only I'll understand that you guys are getting. I can see only 2 responses. One is by Murli, second one is by Darshini. What about other guys? Is it clear?
Yes, people.
Perfect. So now it's time to, we were discussing this, no? So first way is you write down scalar dot fit, then you write down scalar dot transform, right? By fitting, it will just fit this object or this instance scalar on your data. On which data? This number variables or NUM variables. But by using scalar dot transform, it will transform that into zeros and one. This one. So area, bedrooms, bathrooms, stories, parking, price will be converted in the range zeros to one. One is for maximum value, zero is for minimum, and it will between zeros to one. Right? Same with this. So instead of that, by writing down fit first, then by writing down transform, there's one simple shortcut that we have, which is fit underscore transform. Right? So if you just see here what they are doing scalar dot fit on data, then they are using transform method. But instead of that, we have a shortcut, right? We can do scalar dot fit underscore transform, which will do fitting and transforming both. Yes or no? So that's what your fit underscore transform is. It will fit to data, then transform it. This fit, what it will do, it will compute the minimum and maximum to be used for letter scaling. And then you have to do transform, which will transform the data into zeros and one. Right? So this is very important. Like most of the time, I personally have faced this question in the interview, that why there is a need of fit underscore transform, or what is the difference between fit transform and fit underscore transform. So this is very simple. And as I give more weightage explaining the simple thing, because that is what expected in the interview. They will not expect that you guys will be understanding, you guys will be having an idea about the complex term. What generally people will do is they will brush up their complex term, they will be clear in that, but they don't have a good idea about the foundation, that is difference between fit transform and fit, right? Or what happens if we, if all the assumptions are not, if linear regression assumptions are not following, right? Very simple questions you can expect, simple and basic one. But that is critical, like you should have an understanding of very basic and fundamentals to answer this. Now it's time to divide your data into X and Y and fit the model for the model building. This Y underscore train is equals to DF underscore train. There is one method, like how you can generally select Y and X is, as we can know, we can use, in Y we have all the, you have target variable, so you can only select the price column, right? Dividing the data into X and Y. So in Y, I'll write on DF of price. That is also possible. That is also fine. And in X train, minus train is equals to this. And X train, I'm going to write down DF underscore train that we have done earlier in our X here, right? The second approach is I can use this DF underscore train. I'll use pop method, which will only select, which will uh, remove price from DF underscore train, and which will only select price in Y underscore train, right? So don't get confused between that list pop and this pop. That pop, what it does, it just removes that, right? So you can consider it will remove DF, it will remove price from DF underscore train, but it will simultaneously store that in Y underscore train. So if you just check what is there in DF underscore train, you guys will be getting only price column, not all the columns, excluding price column, right? So that is second way in which you can perform the scaling part, not scaling, splitting your data into X train and Y train. Is it fine? Is this thing clear?
Yes, sir.
Okay, excellent.
Yes,
Now,
sir.
yes, good. Now, we are going to build our model. It's time to build the model. So let's put heading as building the model. And this time we will be using the linear regression function from scikit-learn for its compatibility with recursive feature engineering, which is a utility from sklearn. So we'll write an RFE, that is recursive feature elimination. So we are going to import RFE and linear regression from sklearn dot feature underscore selection. We are going to import RFE, that is capital RFE. Yes. And from sklearn dot linear underscore model, we'll import linear regression. So if you don't know RFE package, you can simply go to official documentation, sklearn, and you can import that package from that. So I can write down uh, from sklearn dot feature selection import RFE. Right now it's time to perform the recursive feature engineering. So I can give heading as running RFE out with the output number of the variable, which is equal to 10. LM is equals to linear regression, open and close bracket, LM dot fit, x underscore train, comma y underscore train, RFE is equals to RFE, LM comma 10, and RFE is equals to RFE dot fit, x underscore train, comma y underscore train. So this is known as running RFE, and this is fitting X train and Y train on that. This generally don't work in Colab. I think that's a bug in Colab. If you do the same thing, see, I'll not modify anything. I'll do the same thing. I'll just download this and I'll use the same thing in uh, Jupyter Notebook, and you guys will see that it is working fine. So earlier also I have spent some time in understanding this, but that is not working in Colab. It says that it takes two positional arguments, but three are given. But anyway, I cannot find three arguments. I only have given two arguments over here, which is LM and 10. Where is the third argument? It's not there, right? So even though if you restart and run all this, you'll not get the error. You'll not be able to resolve this error. Instead of that, I'll suggest you guys to go with the Jupyter Notebook for this at least. Right? There might be some modification that we need to explore and see. So, but that is something which will take time and will not spend time on that. Right? Now I'll just show you the same thing. Like I will import the same file in my Jupyter Notebook without doing any modification. Ruby 29th September. Let's create new folder. Let's rename this as multi linear regression RFE. And let's just upload that file. This is your file and this is your data. Housing.csv. Simple. And if you just see this, I think only one small change that we need to do is, okay, this is also fine. It's already done, pd.read underscore csv. If I just restart and run all this, I'll be able to get output for RFE. Can you see this? We are getting the same output. Here, we are not getting the output, right? So anyway, technically, if you just see it, it says it asks us that it suggests us that we should only pass two positional argument, which is allowed in RFE package, and we are not adding third argument, right? So if I am adding this third argument, then it should give the error that is acceptable. But anyway, if third argument is not there, so how it is not fitting, right? So let's do it over here now. Now it's time to just take out a list in zip format by using x underscore train dot columns and RFE underscore support underscore comma RFE underscore or RFE dot ranking. So the procedure that I have explained, like it take all the independent variables, it will find highest probability, it will remove that. Then let's say first time if you have 30 variables, then it will be 29. Then again highest probability will be removed, it will be 28. This procedure it will not do manually. It will use this RFE package to do this procedure, and you will see that it should be dot support. You'll see that area is first, bedroom is first, bathroom is first. These are the rankings. Like you should consider only this. Right now, what I'll do is I'll just make a column is equals to x underscore train dot columns RFE dot support underscore. I'll just select column. What is there in column? So these are the columns that I have. And x underscore train dot columns of the column which this RFE support is not selected. So RFE dot support underscore and negation of that. This is negation, right? So RFE support, in RFE support, we have these columns. In RFE support, we don't have this column. Basement, semi-furnished, and this out of x underscore train. In x underscore train columns, means these are the columns that we have in x underscore train, but not in RFE underscore support. You can write down this. These columns are in x underscore train, but not in RFE underscore support or RFE dot support underscore. Right? And now you guys are pretty much familiar with how do you build the model using stats model for the detailed statistics, which is nothing but creating x underscore test data frame with RFE with selected variables. I'll write on x underscore train underscore RFE is equals to x underscore train column. And I'm going to add a constant variable, which is import stats models dot API as SM x underscore train underscore RFE equals to SM dot add underscore constant. We need to add a constant, right? Because by default, yes, who will explain this, why we are adding constant over here? You'll be able to understand only if you have revised this particular topic. Right. Well, I'll leave this point up to you, and I want answer for that, like why we are adding a constant. Why we are adding constant? Yes, guys. Why we are adding constant? Yes, everyone. Why we are adding a constant? Nobody knows this.
So this is for the data to best fit in the model people.
No, it's very simple. I think you guys have not revised this. Very simple. To add intercept. Yes, Murli. Murli, can you unmute and speak?
Hello.
Yes. Yes.
Uh, can you hear
Yeah.
me?
Yes, yes, yes. Go ahead.
Uh, for adding construct, we ensure that the regression model includes an intercept cell.
Very good. Excellent. Excellent. See, only who will answer this question is only the one who has revised this, right? And I have told you, like, this is very important point that by default stat model will consider that your line will pass through the origin, but it is not the case. You need to write down a constant for that. Constant in the sense this constant y is equals to mx plus c. So if you just add that, it will be from that particular intercept. So intercept will we are not considering if you use only default stats model library, right? So that's the reason we generally write down add underscore constant over here, right? So only two guys have got this correct. One is Murli, another one is Darshit. Now, if you see, bedrooms is insignificant in presence of other variables. Like bedroom has high probability, which is 0 point. Where is bedroom? Here. Okay. 0.037. This is high probability or standard error, you can say, amongst the other, right? So 0.037 is for bedrooms. So it is insignificant in presence of other variables and can be dropped. Right? So I'll write down x underscore train underscore new will be x underscore train underscore RFE dot drop bedrooms column comma access is equals to 1. And we are kind of rebuilding the model without bedrooms. So I'm going to add constant variable. I'm going to import stats models dot API as SM, and I'm going to write on x underscore train underscore LM is equals to SM dot add underscore constant x underscore train underscore new. And I'm going to write on LM is equals to LM SM dot OLS. In that I'm going to pass y underscore train, comma x underscore train underscore LM dot fit, open and close bracket, and I'm going to run the linear model. So let's see the summary of our linear model. I'm going to write a print lm dot summary, open and close bracket. Now I think area should be the one which we should remove. Just a minute. Here we have remove bedrooms. Yeah, sorry, we need to check this probability. My bad. We need to check this one because this is standard error, no? We need to check probability, which is 0.074 for bedrooms and which is highest for bedroom except constant. This is constant that we have added, right? Apart from that, we have all the independent variables, which is 0, 0.74, and this one. So just at this point, make a correction that we should check this constant, not this error. And it is higher for bedrooms, so we are dropping that, which is insignificant. So this probability will tell you that, uh, will give you an idea about the insignificant variables, which is uh, bedroom in this case, by just looking at the probability out there. If you just see hypothesis testing concept, you'll be able to get that, but which is not there in your syllabus. That's the reason we are not taking this. Hypothesis testing will give you an idea about why we should compare the probability with 0.5, right? So in simple words, I'll just explain like why it is 0.5, because we considered as 5% threshold. Like if 5% error is there in my hypothesis, in my assumptions, that is allowed, right? And as you know, nothing in this world is will be able to follow strictly all the assumptions of the linear regression. So we set a threshold as 5% here and there is allowed. So 2.5% to the left hand side, 2.5% to the right hand side is allowed in the distribution. That is my allowed error, right? That is my allowed error here and here, right? So that's why we take 5%. And if it is greater than 5, that is 0.05. 5% means 0.05, right? It should be 0.05. Then we consider that this is following, like bedroom is having more than 5% error that we have assumed, which is not allowed, right? For us 5% is allowed, but it has more 2.5% error, which is not allowed for us. So that's the reason we are removing that. Then now after this, we have, after dropping bedrooms, we are again checking the probability, and which is in a limited, which is in controlled, right? This is in control. But only thing is constant, but that is something which we should have, even though if we drop that, that is also fine. So let's drop this x underscore train underscore new dot drop. According to this summary, it suggests us to drop constant because its probability is high. And the thing that we check to find the multicollinearity, we are going to deal with that. So that is our hero, right? That is our hero entry, you can consider. So what do we use to check multicollinearity? Yes, guys. What do we do, guys? What do we do to check multicollinearity? Which tool we use? How do we detect multicollinearity? Yes, everyone.
We can use correlation matrix and maps.
Right. But that is not valid, no? What I told is this is just give you guys an idea about whether there is a multicollinearity or not. But which tool we use is we use VIF, variance inflation factor. And if it is greater than 10, it is definitely high. But on a safer note, safer side, we should consider it should be greater than 5. It should be greater than 5. VIF not should be. If it is greater than 5, we say that 101% my multicollinearity is there in my data. Right? If it is less than 5, that is totally allowed. But if it is greater than 5, it is not allowed for us. Right? This is fine, but you guys will not get a quantitative idea about the multicollinearity. If it is present, then can you just confirm me? Right? This is a proof. This is your proof for multicollinearity. Right? Similarly, in order to just plot the outliers, check outliers, what do we have seen? How do we uh, check the outliers? We can plot distribution, right? We can check descriptive statistics. But is it a legitimate method? Does it give confirmation about the outliers? No. What do we use is we use this. And what is this? What is this, guys? Box plot. So remember, box plot is it gives confirmation about the outliers. It's 101%. It gives you that I have outliers and I can prove you guys that it is here. These are the outliers. Similarly, to just prove like 101% confirmation, to get confirmation about the VI, do we have it or not? What do we do is we will make use of VIF. So this is our hero. So we'll calculate the VIFs for the new model from stats models dot stats dot outliers underscore influence. We are going to import variance inflation factor. VIF is equals to PD dot data frame open and close bracket. Capital X is equals to X underscore train dot underscore new VIF of features is equals to X dot columns VIF of VIF is equals to variance inflation factor that is X dot values comma I or I in range X dot shape of 1 and VIF of VIF is equals to round VIF of VIF comma 2. VIF is equals to VIF dot sort underscore values by we are going to sort it by VIF comma ascending equals to false. And then we'll find VIF. So in area, this is your VIF, main road, this is your VIF. And do we have any column, any feature which has VIF greater than 5. Do we have any feature? Any column? Yes.
No,
Yes.
no.
So do we have multicollinearity? Can I say that? Can I have multicollinearity in the data? I don't have, right? It's a problem, and we don't have that. Means we don't have association between different independent variables, due to which I cannot able to separate out the effect of a single variable that it has with the target variable, right? I cannot separate that out. This is my data frame. My target variable is price. But if I have multicollinearity, let's say area and bedrooms are correlated, are highly associated. So I cannot separate out what effect single-handedly area has on price or what effect bedroom has on price. So it should be less associated. And which thing will give you guys an idea about that is VIF. So VIF is a tool which gives us an idea about that. What idea? That we should have less multicollinearity by just having a look at the VIF for all the models out there, right? So I'll just explain these lines of code. Like what is happening is we are importing necessary package. We are creating a blank data frame initially. VIF is a blank data frame. In that, we are just uh, considering x equals to x underscore train new. In x, what do you have? You have x train new. And what is there? Basically, in x underscore train new, you have dropped constant as well as bedroom. So apart from bedroom and constant, whatever is there in your data frame, we have that in x, right? We are using this VIF blank data frame. In that, we are adding a column. So earlier my data frame was a blank. Now I'm adding a column. My column name is features. So capital F feature column is added by using line number 6. In that, what do you have? You have x dot columns. So in x, what do you have? Except constant and bedrooms, whatever was there will be here, x dot columns. So if you write down x dot columns, you'll get an idea like what is there in x dot columns. So this is the x dot columns. And same thing you can see over here, right? The next, line number 7. In line number 7, what do you have? In line number 7, you have VIF is equals to VIF. In that, we are using this variance inflation factor, and we are passing one by one value, like x dot values uh, will get one column at a time because we are passing a loop, for loop. In what range? X dot shape of 1. So what will happen is it will calculate VIF by taking, suppose first column is area. So for area, it will calculate VIF. Then second, I will be equals to 2. Uh, Variance inflation factor between x dot values and I in range is x dot shape 1. X dot shape 1 will be only first record. X dot shape of 1 will be only first. Okay, shape means this 9. How many columns do we have in this? 9. So for I in range of what? It will be, I'll simplify this for you. For I in range of x dot shape 1, which is 9, right? And between x dot values. So you are getting variance inflation factor between your this x data What is there in X? You have all the independent variables and one column. So it is calculated like this. Like suppose you want to calculate VF. So VF, if area is calculated by using variance filtration factor, then bathroom is calculated, stories, main road, and it is getting stored over here, right? Anyway, nobody will ask you the calculation of VIF. You only need to understand how do we write down this code. And then we are rounding this off with the 2 decimal places. So suppose if I am getting my VIF as 4.5290, so it will be 4.52. If my VIF is 4.838, it will be 4.84, like that, right? That is what we have. And then VIF is equals to VIF dot sort underscore values. We are sorting these values by VIF column. Ascending is equals to false. That's what we have. Simple. So sorting it based on the VIF column, higher value should come first, lower should come last. That is what we have. Right? Now, I think we should have a break. After this, we are going to see the residual analysis. Of the train data. So our linear regression model assumes that the error term must have normal distribution, right? Error terms are also normally distributed, which is in fact one of the major assumptions of linear regression. So let us plot the histogram of the error terms and see what it looks like. So y underscore train underscore price is equals to lm dot predict x underscore train underscore lm, and we are going to plot the diagram. Like you are going to check, you are going to plot a histogram or a distribution, and it should be normally distributed. 50% to the left hand side, 50% to the right hand side, and histogram of what? Histogram of error terms or residual terms. So that's your entire agenda over here. So kind of we are just validating the assumptions of linear regression. One of the major assumption, which is error terms are also normally distributed, which you can get to see in our notes as well, right? Here we have discussed that very first point. We have discussed, right? Assumptions of linear regression. Yes, guys. I remember we have done this. Assumptions of linear regression. It will be there in that car price prediction model. Sorry, not car price, that mileage MPG. This one. This is stats model. Okay. Mhm. Here, right. Here I have explained all the assumptions that we have for linear regression, right? Yeah, these are the assumptions. Do you guys remember now this 5 assumptions that we have discussed? Okay, perfect. So let us have a break for 10 to 12 minutes. And after the break, we can just finish this particular thing. And if time permits, we can start with the logistic regression part. Right? So it's 11:05. Let us have 12 minutes break till 11:17. Yes, guys, now you will be having a quiz. So you can start now.
Thanks. We'll be sharing the link. Everyone, please join fast. We'll start within 1 to 2 minutes. Thank you, everyone. We are done with the count, so we can continue with the session. Thank you.
Yes, thank you. So now let's do the residual analysis. We'll just plot a distribution plot. So I'm going to plot the histogram of the error terms. That is figure is equals to plt dot sub plt dot figure open close bracket sns dot dist plot y underscore train minus y underscore train underscore price. Right? Y underscore train underscore price is your predicted value, and y underscore train is your actual value. So we are plotting a distribution plot between the error. And what is your error? The actual minus predicted. Actual minus predicted. Yes or no? And comma beans is equals to 20. Figure dot sup title error terms comma font size is equals to 20. plt dot x label is errors comma font size is equals to 18. Right? So we'll just give heading as plot heading, and we'll just, this is your X element, right? PLT is not defined. I think we need to import this. We'll import matplotlib dot py plot as PLT. We'll import cbon and SNS and percentage matplotlib in line. So this is your error terms, right? Now it's time to make predictions. Applying scaling on the test set numerical underscore variables is equals to area comma bedrooms comma bathrooms comma stories comma parking comma price. And we'll write down tf underscore test of numerical variables is equals to scalar dot transform df underscore test of numerical variables. So we are applying scaling on this numerical variables to just make a predictions. That is scalar underscore transform. And we are going to dividing the data into x underscore test and y underscore test. We'll write on y underscore test is equals to df underscore test dot pop price column, and x underscore test is equals to df underscore test. Now let us use our model to make predictions. So I'm going to create x underscore test new data frame by dropping variables from x underscore test underscore new is equals to x underscore test x underscore train underscore new dot columns, and I'm going to add constant variable. So x underscore test underscore new is equals to sm dot add underscore constant. So let's go test on this one. Now I'm going to make predictions. Y underscore grade is equals to lm dot predict underscore test underscore new. And now I'm going to do the model evaluation, which is nothing but plotting y underscore test and y underscore grade to understand the spread. So figure is equals to plt dot figure plt dot scatter y underscore test comma y underscore grade figure dot sup title y underscore test versus y underscore grade font size is 20 plt dot x label y underscore test comma font size equals to 18 and plt dot y label y underscore grade font size is equals to 16. So this is a plot heading. This is your X label and this is your Y label. So on the X axis you have Y test, on Y axis you have Y pred, right? Now what I'll do is I'll just quickly upload this on your drive. And if you have any questions, you can ask, otherwise we'll just stop here for the day. So this is completed, like we have seen all the things that we have discussed for the multiple linear regression, starting from your starting from your how do we go with the multiple linear regression model by adding a variables, then moving from simple linear regression to multiple linear regression, what are the different problems that we have and how do we detect that, how do we remove that, how do we remove multicollinearity, how do we uh, deal with the categorical variable, how do we do the scaling in Python, and then what, how do we generally select the features by using recursive feature elimination. Everything is discussed. Now, in the next session, that is in tomorrow's session, we are going to start with the new machine learning model, that is your uh, logistic regression. Logistic regression. And additionally, from my end, I am going to give you multiple assignments uh, for your practice, which will be nothing but which will be related to your linear regression, right? So there will be a uh, assignment on bike sharing dataset, which will predominantly test your understanding and knowledge of what you have learned till now in linear regression, multiple regression, and there will be a PDF provided to you that I'll do it in tomorrow's session. This is from my end, not from GUI's end. And in that PDF, you guys will be having a company description. You will be having a dataset description, like what this dataset is all about, what this company is all about, and you guys will be having a questionnaire, right? There will be a separate dataset which I'm going to provide, and you have to take care of this models, this questionnaire. You have to solve that by using. You can obviously refer what we have. You can obviously refer this RFE notebook or the previous notebooks that we have done to solve this, and it will be very easy. So you can consider this as your real-time experience of working as a data scientist or machine learning engineer. Because what happens is you also will get a data and you'll get a description about the company and its data set. You'll get a questionnaire. You have to solve this and write down your analysis in the form of presentation, that is PPT, as well as your IPYNB notebook, that is Python notebook. So here also we'll follow the same trend and pattern. You guys need to analyze these questions by using Python, and you guys have to create an insight, right? You have to write down your findings that you have calculated from the coding that you have done, and there will be point-wise description. So you can submit this. I can give you 10 days time. It's for 10th December. You can take till 24th December, and you can submit that. uh, let's say here we'll create a new folder for submission of bike sharing assignment, and in that I think you don't have permission to add files over here, right? Only viewer access is there. Okay. What can we do? How you guys can share this or upload this? Okay, I'll create my own folder. What I'll do is I'll create a new folder for GUI submissions here, and here I'll just create new folder for bike sharing assignment. I'll provide edit access to you, or just confirm by just having viewer access. Can you just add a folder to that? I think it will not be there. It's not there, right? If I just provide viewer access, can you guys create folder to this, add files to this? No, it's not there, right? So I can copy this, and here you have to submit your files. So for an example, Darshini is submitting her file. So she'll write down her name, and in that she'll create the submission, right? So likewise you can do. And anyway, this assignment that I am going to share will be here. Assignment, right? So tomorrow we'll discuss the problem statement and what we are interested to do that in the assignment. So likewise, you guys will be getting at least 4 to 5 assignments apart from your assignments which are provided by GUI. So that will be a real-time practice you can consider, right? Okay. So if you have any questions now, you can ask. Otherwise, we can stop here. Yes, guys. No questions? Perfect. All right, then we'll stop here for the day. Thank you and happy learning. Bye.
Okay, Vibhor.